Welcome everyone. It is 3 p.m. and it's time for the Server Room Show. This is episode 67. Today I will talk about AIX, which is IBM's version of the Unix operating system. I have always liked operating systems, computers in general. Operating systems make computers become something usable and something you can actually interact with to do things versus what they are in reality, which is just a bunch of electronic parts shoved together in some pretty box. While growing up, I have been exposed to the home computer boom, which was at its height during the 1980s, with iconic members like the Commodore 64 and some Z80 clones like the HT-1080Z, which were available at high schools during the 1983 to 1986 period, which was my infancy in Hungary. I left some links on the bottom of the show notes and some images in the show notes as well. I do still remember the first time somewhere around the late 1987, 1988 when I first had the opportunity to touch and try one of these HT-1080Z and play with it in high school, where my father worked at that time. And I remember he took me one morning early. We took the train and we went to this high school where he was working, and I had the chance to try the HT-1080Z there, and yeah, it's a very nice memory. The HT-1080Z was built by Híradás Technika Szövetkezet after purchasing the license for the Hong Kong-based EACA company's Video Genie computer, which looks identical therefore to the HT-1080Z, just the logos are different. The Video Genie version sold in North America was called the PMC-80. The Video Genie itself was considered a TRS-80 Model 1 clone, although the two had hardware and software differences. I saw Commodore's BASIC, MS-DOS, and later on some novel network, Windows 3.1, OS2, BOS, Linux, Mac OS, BSD, then FreeBSD as I grew up and as I grew older. It was during that time I've seen once a Pegasus motherboard or system which was running, if I'm not mistaken, Amiga OS with true multitasking and multimedia capabilities, which was very unique and not affordable to me at all. And to this day, I have never forgot the experience or the way it made me smile back then. But I have only heard about, but never had any experience or exposure to ZOS or ZVM from IBM or Unix of any kind like HPUX, Solaris or AIX of IBM's. They were all very mystical and unreachable for me while I was a kid, and even later when I was in my way through adulthood. When eventually I became an IT professional, I thought I would get exposure to all of these systems I have lusted after to know more about for years and years. But the sad truth is that I have never had any, exposure to them or experience with them through my jobs. With the advent of virtualization and cloud computing, these things are somewhat changing now, but still it is not easy and most of the time not free to tinker around with these systems, even just for even if it's just for your own amusement or educational reasons to pick some new or old knowledge up. Big companies like IBM, AIX, and ZOS, and HP with HPUX or OpenVMS are not exactly on the forefront to accommodate home labs or hobbyists with ways to run these systems for free for non-profit and home use in their home labs. There are some options open to partners and developers through businesses, through contracts for me at least huge amounts of money per year, which I'm not sure a single individual can spare. Again, for me, these are big amounts of money. For companies, I understand this money might be nothing. I'm talking about the realms of 5 to 10,000 euros, for example, a developer license for a year for IBM's ZOS developer platform, where you can run on top of Linux a complete mainframe, so to say, with ZOS and all the developer tools and bells and whistles and the kind folks of IBM charge around between 5 to 10,000 euros for the USB token to run and use these tools. Shows this again, this kind of not being very open towards the community of these home labbers and thinkers and enthusiasts. Nothing shows it better than after many years of successful running, HP is discontinuing the OpenVMS hobbyist license for individuals on the 21st of December 2021, and it will definitely mark an end of an era. So AIX stands for Advanced Interactive Executive, is a series of proprietary Unix operating systems developed and sold by IBM for several of its computer platforms, originally released for the IBM RT PC RISC workstation. AIX now supports or has supported a wide variety of hardware platforms, including the IBM RS-6000 series and later Power and PowerPC based systems, IBM System I, System-370 mainframes, the IBM PS2 personal computers, and at some point the Apple Network Server. AIX is based on UNIX System 5 with 4.c BSD compatible extensions. It is one of 4 commercial operating systems that have versions certified to the Open Group's UNIX 03 standard, the others being macOS, HPUX, and Euler OS. The AIX family of operating systems debuted in 1986, became the standard operating system for the RS-6000 series on its launch in 1990, and is still actively developed by IBM. It is currently supported on IBM Power systems alongside IBM I and Linux. AIX was the first operating system to have a journaling file system, and IBM has continuously enhanced the software with features such as processor, disk, and network virtualization, dynamic hardware resource allocation, including fractional processor units, and reliability engineering ported from its mainframe designs. A bit about the history. As we saw on the episode of UNIX on this podcast, UNIX started life at AT&T's Bell Labs Research Center in the early 1970s, running on DEC mini-computers. By 1976, the operating system was in use at various academic institutions, including Princeton, where Tom Lyon and others ported it to the S370 to run as a guest OS under VM370. This port would later grow out to become UTS, a mainframe Unix offering by IBM's competitor Amdahl Corporation. IBM's own involvement in Unix can be dated to 1979, when it assisted Bell Labs in doing its own Unix port to the 370 to be used as a build host for the 5ESS switch software. In the process, IBM made modifications to the TSS370 hypervisor to better support Unix. It took until 1985 for IBM to offer its own Unix on the S370 platform, AIX-370, which was developed by Interactive Systems Corporation and intended by IBM to compete with Amdahl UTS. The operating system offered special facilities for interoperating with PCIX, interactive IBM's version of Unix for IBM PC compatible hardware, and was licensed at 10,000 per 16 concurrent users. AIX version 1 introduced in 1986 for the IBM RT-PC workstation was based on Unix System 5 releases 1 and 2. In developing AIX, IBM and Interactive Systems Corporation, whom IBM contracted, also incorporated source code from 4.2 and 4.3 BSD Unix. The IBM RT-PC workstation is a family of workstation computers from IBM introduced in 1986. These were the first commercial computers from IBM that were based on reduced instruction set computer RISC architecture. The RT-PC used IBM's proprietary ROMP microprocessor, which commercialized technologies pioneered by IBM Research 801 experiment mini computer. The 801 was the first RISC computer of IBM's. The RT-PC ran 3 operating systems: AIX, the Academic Operating System AOS, or PIC. The RT-PC's performance was relatively poor compared to other contemporary workstations, and it had little commercial success as a result. IBM responded by introducing the RISC Systems 6000 workstations in 1990, which used the new IBM proprietary RISC processor, the Power 1. All RT-PC models were discontinued by May 1991. The primary operating system for the RT was AIX version 2. Much of the AIX version 2 kernel was written in a variant of the PLI programming language, the PL8, which proved troublesome during the migration to AIX version 3. AIX version 2 included full TCP/IP networking support, as well as SNA and 2 networking file systems, NFS licensed from Sun Microsystems, and IBM Distributed Services DS. DS had the distinction of being built on top of SNA, and thereby being fully compatible with DS on the IBM mid-range AS400 and mainframe systems. For the graphical user interfaces, AIX version 2 came with the X10R3 and later the X10R4 and the X11 releases of the X Windows system from MIT, together with the Athena widget set. Compilers for C and Fortran programming languages were available. Some RT-PCs were also shipped with the academic operating system and IBM port of 4.3 BSD Unix to the RT-PC. It was offered as an alternative to AIX. The usual RT-PC operating system to US universities eligible for an IBM educational discount. AOS added a few extra features to 4.3 BSD, notably NFS and an almost NCC compliant C compiler. A later version of AOS existed that was derived from 4.3 BSD Reno, but it was not widely distributed. IBM PS2 series. AIX PS2, also known as AIX 386, was developed by Locus Computing Corporation under contract to IBM. AIX PS2 first released in October 1988 ran on IBM PS2 personal computers with Intel 386 and compatible processors, AIX PS2 1.3, AIX Windows Desktop. The product was announced in September 1988 with a baseline tag price of 595 US dollars, although some utilities like UUCP were included in a separate extension package priced at $250. NROF and TROF for AIX were also sold separately in a text formatting system package priced at $200. The TCP/IP stack for AIX PS2 retailed for another $300. The X window package was priced at 195 US dollars and featured a graphical environment called the AIX Windows Desktop, based on IXI's X Desktop. The C and Fortran compilers each had a price tag of 275 US dollars. Locus also made available their DOS merge virtual machine environment for AIX, which could run MS-DOS 3.3 applications inside AIX. DOS merge was sold separately for another $250. IBM also offered $150 AIX PS2 DOS server program, which provided file server and print server services for client computers running PC-DOS 3.3. The last version of PS2 AIX is 1.3. It was released in 1992 and announced to add support for non-IBM, non-microchannel computers as well. Support for PS2 AIX ended in March 1995. AIX versions 3 and 4. Among other variants, IBM later produced AIX version 3, also known as AIX 6000, based on System 5 Release 3 for their power-based RS6000 platform. Since 1990, AIX has served as the primary operating system for the RS6000, later renamed IBM eServer P series, then IBM System P, and now IBM Power Systems. IBM loves renaming things, as you see. AIX version 4, introduced in 1994, added symmetric multiprocessing with the introduction of the first RS6000 SMP servers and continued to evolve through the 1990s, culminating with AIX 4.3.3 in 1999. Version 4.1 in a slightly modified form was also the standard operating system for the Apple network server system sold by Apple Computer to complement the Macintosh line. RISC System 6000 or RS6000 is a family of RISC-based Unix servers, workstations, and supercomputers made by IBM in the 1990s. The RS6000 family replaced the IBM RTPC computer platform in February 1990 and was the first computer line to see the use of IBM's Power and PowerPC based microprocessors. In October 2000, the RS6000 brand was retired for power-based servers and replaced by the eServer P series. Workstations continued under the RS6000 brand until 2002, when new power-based workstations were released under the IntelliStation Power brand. AIX version 5, AIX 5L 5.1, May the 4th, 2001. AIX 5.1 on Power 4 architecture made a leap forward towards future virtualization on IBM Power. 64-bit kernel were installed by default but not enabled. The ability to run logical partitions on Power 4. Logical partition, or LPAR, is a subset of computer's hardware resources virtualized as a separate computer. In effect, a physical machine can be partitioned into multiple logical partitions, each hosting a separate instance of an operating system. GFS2 file system, up to 1 terabyte file system, with up to 1 terabyte file size support, the journaling file system too. Reliable, scalable cluster technology, Linux compatible program interface, workload manager, graphical user interface, and functional upgrades. AIX 5L 5.2 at October the 18th of 2002 brought even more enhancements. Dynamic logical partitioning for processors, memory, and I/O. Dynamic capacity upgrade on demand, enhancements to scalability and workload manager, enhancements to enterprise storage management, cluster systems management for monitoring and administering multiple machines, both AIX and Linux from a single point of control, advanced RAS features, additional security features and enhancements, network enhancements including mobile IPv6, SNMP version 3 and upgrade to Bind version 9, APIs from the latest C language and single UNIX specification standards, AIX 5L 5.3 of August 13, 2004, the enhancements which came with AIX 5L 5.3 combined with the Power 5 series enabled an advanced power virtualization platform which is still in use today on power systems in a form of Power VM. Micro-partitioning support for a single processor being shared by up to 10 logical partitions. Virtual SCSI disks that allow partitions to access storage without requiring a physical storage adapter. Virtual networking, virtual Ethernet provides high-speed connections between partitions. Shared Ethernet adapter provides connectivity between internal and external VLANs. NFS version 4. AIX version 6 and newer. AIX 6 was announced in May 2007 and it ran as an open beta from June 2007 until the general availability of AIX 6.1 on November the 9th, 2007. Major new features in AIX 6.1 included full role-based access control, workload partitions, which enabled application mobility, enhanced security, addition of AES encryption type for NFS versions 3 and version 4, and live partition mobility on the Power 6 hardware. AIX 7.1 was announced in April 2010 and an open beta ran until general availability of AIX 7.1 in September 2010. Several new features including better scalability, enhanced clustering and management capabilities were added. AIX 7.1 includes a new built-in clustering capability called Cluster-Aware AIX. AIX is able to organize multiple LPARs through the multipath communications channel to neighboring CPUs, enabling very high-speed communication between processors. This enables multi-terabyte memory address range and page table access to support global petabyte shared memory space for AIX Power 7 clusters, so that software developers can program a cluster as if it were a single system without using message passing like semaphore-controlled inter-process communication. AIX administrators can use this new capability to cluster a pool of AIX nodes. By default, AIX version 7.1 pins kernel memory and includes support to allow applications to pin their kernel stack. Pinning kernel memory and the kernel stack for applications with real-time requirements can provide performance improvements by ensuring that the kernel memory and kernel stack for an application is not paged out. AIX 7.2 was announced in October 2015 and released in December 2015. AIX 7.2 principal feature is the live kernel update capability, which allows OS fixes to replace the entire AIX kernel with no impact to applications by live migrating workloads to a temporary surrogate AIX OS partition while the original OS partition is being patched. AIX 7.2 was also restructured to remove obsolete components. The networking component BOSNet TCP client was repackaged and to allow additional installation flexibility. Unlike AIX 7.1, AIX 7.2 is only supported on systems based on Power 7 or later processors. AIX 7.3 is due to be released in Q4 of 2021, and with that marking or continuing a 35-year tradition of innovation with enhanced capabilities that deliver resiliency, security, and the scale needed to get IT environments hybrid cloud ready. So yes, that's it is there, folks. 35 years and counting for AIX. A bit more about AIX in this part of this episode. The default shell was Burn shell up to AIX version 3 and was changed in AIX version 4. The default graphical user interface is CDE, Common Desktop Environment. As part of the Linux Affinity introduced in AIX version 5, and thanks to the AIX toolbox for Linux applications, certain set of open source tools, kind of a core set of some of the most common tools like development tools and libraries are available in RPM package form, like curl, Samba, and PostgreSQL, sed, mat. I left a link in the show notes so you can check for yourself if your favorite tools or tool is included or not. Smith, the system management interface tool, it allows user to navigate a menu hierarchy of commands rather than using the command line to do system management and to interface with the system. Invocation is typically achieved with the command smith. Experienced system administrators make use of the F6 function key, which generates the command line that smith will invoke to complete the task you asked it to perform. It also generates a log of commands that are performed, so you can keep record and look it up. And it also generates records a script file which records the commands with the command flags and parameters which was used. And you can use the script files of Smith to use it to create executable shell scripts to rerun system configuration tasks. So it's kind of handy. And this, including with the log files, you can use it to keep track of things. Smith and Smithy refer to the same program. Through Smithy invokes the text-based version, while Smith will invoke an X Windows system-based interface. If possible, however, if Smith determines that X Windows system capabilities are not present, then the text-based version instead will be running. And this is how much I was able to fit into this episode. I think that the rest I will leave for a second episode. At least I will try to, because like this we covered the history of AIX and a little bit of my background to these things, and in a second part episode, part 2, we can talk about how to get your hands on AIX. We can talk about the community, my experience about it, and I can mention people I grateful for helping me getting my experience with AIX, and I will share with you some ways you can do it. So yeah, eventually it ended up to be a 2-part episode. I will mark it in the show notes, and then see you next Saturday for part 2 of AIX.